Yeah, hello, this is Dieter from Germany speaking. Thanks a lot for this great images of Trevor Waddle. And I want to show you now what you can do with this kind of data in the BitPlane software Imaris. So it's already opened here. What we see is one of these Dragonfly data sets, which were shown in the beginning of the presentation. So basically, I just want to show you the result, which I got in Imaris. So we have here the one of the channels reconstructed. So we have the outside of the Dragonfly as a reference. And then if we look inside, I open this clipping plane here so you can look inside. We see inside we have the nerve reconstructed as a vector object. And that means with these vector objects you can answer questions like what are the lengths of the neuron, how many branching points do I have, what are the diameters, and especially here one of the questions was how many of first-level side branches do we have inside the whole data set. So this is the result. So let me show you where we started from. So this is basically the original data set which we got. It has 3 channels, and the main channel of interest is the red one. So we have the blue channel, which we don't need now, and the green one here. And then we have the red channel, which shows the stained nerve. If you have a closer look at this staining, we see it's really nice for such a big object. It's beautiful, but still it has some challenges which you have to overcome when you do the segmentation. So first we see in this area here, we have quite a lot of objects stained here as well, which are not directly part of the nerve. So those have to be excluded from the analysis. And if you look closer at the staining as well of the fibers, you see it's not completely continuous. So we have some gaps inside, and but Imaris can handle this quite well. So this data set has 2 areas here. This area is a little bit more challenging and has these background objects. And then if we move further, we see this area it's quite clear. So we don't have a lot of background, but still the punctuated staining is there. And overall, the staining is a little bit weaker. So to overcome these differences, what I did, I did the reconstruction in 2 subregions. So first, I did this subregion, and then I did that subregion, and tuned the parameters for the different regions a little bit, so we could get nice results, even with the automatic detection. And then in the end, I just joined these 2 vector objects, which is quite easy. So I cannot show you the full preparation because this autopath method which we use here takes a while to calculate, so that would go over time. But I want to show you a little bit from the result. So just to mention the autopath, the idea is like this, that we have a starting area, which is here. So we mark this with a point, and then the software will mark the boutons and the nerve fibers with the smaller spots. And then these smaller spots, then are connected to the big spot by going through the most bright intensities of the data set. So with this way we get a vector. And the raw result will then be already quite well, but you would need to do some editing afterwards. So Imaris has as well a rich amount of editing tools, and just show you what the first editing I had to do here was that directly at the main branch here there's a lot of brightness going on. So I got some false positive small side branches, and there are tools, for instance, here where you can select branches depending on their length. Yes. For instance, here I used the relative branch length tool. So it basically selects branches which are shorter than a certain length, depending as well on the diameter of the branch they come up from. So in the end, it's a little bit more sophisticated than just taking the length. It's just a ratio as well, which depends on the diameter of the branch where they spring off. So this was done then more general, so that basically that will select small branches on the full data set, and then in the end you just press delete and delete them all with one stroke. So this is quite automatic. And now I want to show you as well a little bit what you can do with manual editing. I didn't have to do too much, but a few branches and were still there, false positives, and a few ones which I had to add as well. So here, for instance, we have one of the false positive branches, and so I can simply select this guy with my mouse. You see it's highlighted, and then you can delete it with a simple mouse click. So this is, of course, not really challenging, selecting objects and then deleting them. A little bit more sophisticated is a tool to manually draw. So first I have to find the location where I have these, which is missing. Here it is. So I'm not sure how good you can see this on the screens because of the video, but maybe you see that here is a structure which is missing. So here no staining is, the staining is a little bit weak, and no branch was added by the software. So we see that in the beginning there is a short branch which we can use as a start, and then I want to draw the rest of this manually. So for this I go to the drawing tab of the filament tool, and there we have different drawing methods. Some are more automatic, some are more manual. Because the automatic one will take as well, again, some calculation, I will just show you one which is fairly manual. This is the auto depth tool. So for this, I need, again, my 3D mouse. So we have this white little box, which I can position with my 2D mouse in the 3D environment. So this works like this, that I position the X and Y with my mouse, and the set position, so in depth, this will be calculated by the software. So first I select the beginning area, and then I press Shift and now follow, hopefully quite accurately, my fiber here. So again, X and Y is set by my mouse, and set is set by software. Okay, and the last curve. That's it. So now it will insert the line, and what you maybe see now that the line is slightly off because I just did this not accurate enough, and but there's some help from the software, so you can switch back to the Edit tab, and then now I select my drawing. It will highlight, and there is a tool which is called Center. So this will recenter the line to the brightest intensities which are in the surroundings. So if you look close, maybe you will see it if it snaps there. So I press it. I have to tell them which channel I want to work, on the first red channel I want to work, and now it will snap it to the center. So this is fine-tuned. The next thing which you maybe notice is that the diameter is constant. So in principle, I could draw as well different diameters by just resizing my drawing box here with the mouse wheel, but I didn't do this. I just draw. And what you can do now is to calculate the diameter automatically by using the diameter tool. Okay, I just use the defaults here for the parameters, which work in most cases, and now you see that this is resized. Okay, so that's basically done. This is what I want to show you for the reconstruction part. And the next thing is that you now have, of course, a lot of statistics. So, for instance, if I select here this part, and I switch to the selection tool, you see that we get quite a long list of. Sorry, I deselected it. Yeah, a long list of statistics. And there are even more in the software. Not everything is activated now, but you get, for instance, information like what is the length, what's the diameter. If you would have spines, for instance, we don't have it here, you would see the number of spines and things like this. So one question here, which Trevor had about this data set was, how many main side branches do we have on the neuron? So we have here, this one is level 1, basically the big one, and then we have second level side branches, which are smaller ones, which go again through the tissue here. The software is able to calculate this by using a little extension. So here on the Tools tab of the filament tracer, you will see Matlab programs. You can add here as well your own written programs, like in Matlab or Python, for instance, or Java. Here, these are programs which are delivered with Amaris. So what I can do now, if I select this and I would press branch hierarchy, the software would recalculate the connection. So it will send the topology and all the diameter information and so on to Matlab. And in Matlab, the tree structure would be recalculated in a way and resorted in a way that we get continuous side branches sorted by the level. So in the moment, for instance, this here, if I click on this, you see it's little segments, and what we need for the count is just the complete structure, the complete second level as one branch. So if you click here, it would calculate this. Again, it takes maybe 1-2 minutes. I don't want to do this now. I just show you the result. So the software, the Matlab extension will feed back into Amaris the result, and this is shown here. So it generates a subgroup, and inside this group we have different levels sorted. You see I can switch on and off the second level. And if you now go for the count of the objects, here you will see this 77 branches, side branches. So like this, you can enhance the software even further. Okay, that concludes my presentation, my very short presentation of Amaris. Of course, there's much more to do in filament tracing, but maybe you can join us for another webinar if you're interested in more details. Thank you.